everyone, this is Mrs. Richart, and today we're going to look at function representations. So to remind everyone, what is a function? So we're thinking about a function like a machine, specifically a vending machine. So a function is a relation with inputs and outputs. Something goes in and something comes out. Every input has one output. That is our definition of a function. Every input has one output. So there's different ways we can represent a function. These are called ordered pairs. This is called a table. We've already looked at this representation called mapping diagrams. And lastly, we have a graph. All of these are used to represent functions. To determine whether tables are functions or not a function, we're going to take a look at the inputs and the outputs. If we look, 1 goes to 2. I put in 2, I get 4. I put in 3, I get 6. I put in 4, I get 8. There's no repeat x values. Now our x values are our inputs and our y values are our outputs. So if this is a function, because every input has one output. If we look at the other table on the right side, we have an issue because 1 goes to 2, but 1 also gives us 8. So once again, 1 gives us 2, and 1 also gives us 8. That's a repeat x value. 1 can only give us one number. It can't give us 2 and 8 at the same time. So this is not a function. 1 has 2 different outputs. That's our reasoning. Looking at our mapping diagrams, we've done this before, so this is a review. If we look on the left side, 1 goes to 2, 2 goes to 4, 3 goes to 6, and 4 goes to 8. We're going to look specifically at the 2 going to 4. Now on the right side, 2 goes to 4, but 2 also goes to 6. And that's the problem when we have 2 arrows coming from the input, the left side. So for the first one, this is a function. Every input has one output. The second one, this is not a function. 2 has 2 different outputs. 2 goes to 4 and 6. That's not allowed. It's a broken vending machine. It's not a function. For our ordered pairs, to remind ourselves, they are written with parentheses and a comma, and that is a point. An ordered pair can also be called a point or a coordinate pair. So the x is the input, that's what you put into the function machine, and the y is the output, that's what comes out of the function machine. The first number is the input or the x, the second number is the output or the y. To determine if these ordered pairs are functions or not, let's take a look at the x values. So 1, 2, 3. I don't have any x's that repeat, so that's a function. Every input has one output. 1 goes to 2, 2 goes to 4, and 3 goes to 6. On the one on the right, we have 1, and we have 2 twice. We have 2 2s. 2 can't go to 4 and 6 at the same time. This is not a function. 2 has 2 different outputs. When we look at graphs, we have a test that we can do. It's called the vertical line test. A vertical line test is this: if you draw a vertical line through a graph and it hits more than one point, then it is not a function. This is a vertical line, so it goes up and down. I'm going to share an animation with you real quickly. So if we're looking at a linear function, I'm going to take this vertical line. Every time it passes, it only touches the graph one time. If I put the quadratic function, every time it's touching it once, it's never touching it more than one time. For this function, It hits it in two places, here and here. So this is not a function. If I put a circle, this is not a function because as you move a vertical line, it hits it twice. So looking at the graph, if we're using the vertical line test, if we look at the left graph, I'm going to put vertical lines that go up and down. I hit 1 point, 1 point, 1 point, 1 point, 1 point, 1 point. That's a function. It passes the vertical line test, or VLT, vertical line test. On the right side, it hits 2 points right here. Because it hits 2 points, it cannot be a function. We have one input of 6 with two outputs of 10 and 15. It does not pass, or it fails the vertical line test, or VLT.